So we'll be talking about two more quadrilaterals, kites and trapezoids. In this video, we'll go ahead and talk about kites and save trapezoids for class. So what is a kite? A kite is basically a quadrilateral that has two pairs of congruent consecutive sides. So most of you have probably seen or drawn a kite before, so you know these two shorter sides. An atypical kite would be congruent, and then these two longer sides would be congruent. So a rhombus is a special kite. So if you think about this, if we had all four sides were congruent, we'd have a special kite, which would be a rhombus. So one of the characteristics of kites that it shares with the rhombus is that the diagonals are perpendicular. So if we call this quadrilateral ABCD, for example, then the diagonals are AC and BD. So if we know that ABCD is a kite, then we know that AC and BD are perpendicular, which then gives us right angles, which gives us right triangles. So we can use things like Pythagorean theorem to find missing lengths, right? Or we can use the right angles to show that they're congruent if we want to prove things about those small triangles. The second thing that we are going over in the book with kites is that one pair of opposite angles are congruent. Okay, so again, if we call this quadrilateral ABCD, the congruent angles are the angles formed by the non-congruent sides, typically along the shorter diagonal. So again, if ABCD is a kite, so we need to know this either by seeing the, you know, marks here on the sides of your quadrilateral, or you actually see the word kite in the given. Then we can say that angle BCD is congruent to angle BAD. And connected to this, which I'm not formally defining, but you can use because you can prove this, this creates basically a reflection, right, of two triangles, a triangle and its reflection, so they're congruent with SAS or SSS if you want to do the reflexive side. So using CPCTC, just a side note here, your non-congruent angles are bisected. So that could come in handy when you have things like example 1 and you're trying to solve information about angles in your kite. So let's do example 1 and we'll wrap up this video. So in kite ABCD, the measure of angle DAB is 54 degrees. The measure of angle CDF is 52 degrees. We want to find each measure, BCD, ABC, FDA. A quick note about these types of problems, if we are using the same information, you actually don't have to do A, then B, then C always. Sometimes it helps to just look at what you can solve for first. But anyway, when I look at part A, I'm looking for BCD, which is this larger angle here, right? Since we know that CDF is 52 degrees, you can do a couple of things. You can remember that. What do we know about these diagonals? They are not just congruent, but they are right angles, right? So you might use your triangle angle sum theorem and say, well, the measure of angle CDF plus the measure of angle CFD plus the measure of angle FCD equals 180. And remember what I was saying earlier, even though we didn't formally state this, you can prove it that this angle is being bisected because we have side angle side congruence or side 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 congruence. So that's something you can use. And let me make that 180 maybe a little bit easier to read. So I might say, let's do this, and then plug in what we know. Once we find angle FCD, I'm going to double it to find the measure of angle BCD, right? So the measure of angle BCD is going to be 2 times the measure of angle FCD. And this is just one way to do it, right? It's not the only way to get around this problem. So I'm going to go ahead and plug in my numbers. So CDF is 52. I know CFD is always 90 there. Plus the measure of angle FCD equals 180, 142. So the measure of angle FCD should be 38 degrees. And since the measure of angle BCD is twice that, we should get the measure of angle BCD equals 76 degrees. Can you think of maybe an alternative way to find the measure of angle BCD? Well, remember what else we know about kites is that the consecutive sides, there's going to be two sides that are congruent, creating an isosceles triangle. So something you might be able to do as well is go 52 plus 52 because your isosceles triangle theorem says the base angles are congruent, right? So these two angles are congruent. 52 plus 52 plus angle BCD should add up to 180, and that's how we can also get 76. So again, often more than one way to get to the final answer. It is up to you and what you see, okay? So how do we find the measure of angle ABC? So ABC is right up there, right? So once again, we know that this is 52 degrees. And like I was saying earlier, you can use your isosceles triangle theorem to say that, okay, this is also 52 degrees, right? And then we know angle DAB is 54 degrees. And like I said earlier, because of CPCTC, when you prove these two triangles ABC and ADC are congruent, we can cut this angle in half. So 54 divided by 2 is going to give me 27 degrees, right? And we always know that the diagonals are perpendicular, so I can once again use my triangle angle sum theorem to find this missing angle, angle ABF. And again, this is just one approach to the problem. You can do this in a different way if you like as well. So I'm going to go ahead and find the measure of angle ABF. So 27 plus 90 plus the measure of angle ABF should add up to 180. So the measure of angle ABF is 63 degrees. And then using my angle addition postulate, the measure of angle ABC should be 63 plus 52, which is going to give me 115 degrees. And again, this is just one way you could have done it. You could have done this in another way. Any thoughts about how you could have done this in a different way? Well, for me, alternatively, I know that all four angles in the kite add up to 360 because it's a quadrilateral. And since we just found the measure of angle BCD at 76 degrees, and we know the whole thing ABC, or excuse me, DAB is 54 degrees, and we should know that these angles are congruent because they are where the non-congruent sides meet. I can go 76 plus 54 plus x equals 360 to find the measure of angle ABC as well. So again, all depends on what you see. Okay, finally we are looking for angle FDA, which conveniently I already found. So let me just show you how I did that again in case you missed it. So FDA is this angle right here, right? And like I said earlier, we knew this is CDF at 52, right? If you want to start all over again, you can always go back to, oh, I'm sorry, we don't even need that 52. You can go back to, sorry, DAB, right? Cut this in half, and this is 27 degrees, this is 90, and then we can find FDA because of that right triangle. Or if you looked in B, we already found that this whole thing is 115, and because they are congruent, right, 115 for ABC is the same thing as CDA, and then we can just take away that 52 from there. But again, this is what I did earlier, right? To get that 63, we know that the measure of angle ABF should equal the measure of angle ADF, because again, those angles are congruent. And since this is an isosceles triangle, these base angles are the same. So the measure of angle not ABF, and ADF, FDA, oh, it's the same. Sorry. Brain fart right there. So I'll just rewrite this. So FDA, it's the same thing as ADF. So then we know the measure of angle FDA is also 63 degrees from right over here in part B. Okay, so that's it. We'll talk about trapezoids in class. Thank you for listening.